Okay, so let's look at some examples of calculating the variance and the standard deviation. So, let's start. Example 1. Lockheed Martin hired 5 college graduates. The starting salaries in thousands for each graduate are shown below. Find the population variance and standard deviation of the starting salaries for Lockheed Martin. Okay, so now I need to figure out what formula I need. Well, as I'm reading this, they give me a hint. Population variance. So what is that formula? That formula says sigma squared is equal to the sum of x minus mu squared all over n. Okay, so now I need to start seeing what I need. Well, I need mu. I need the population mean. I need the population mean. So let's figure out what mu is, because I need that to plug into my formula. Mu, we know we have to take the sum of the x's divided by how many there are. 41 plus 38 plus 39 plus 45 plus 47, all divided by 5. I'm going to pull up my calculator, add those up. 41 plus 38 plus 39 plus 45 plus 47. 210 divided by 5, that gets me 42. So my mean is 42. Now, when I do variance, I like to set a table up to help me visualize what's all going on, because there's a lot, and I want to keep it straight. So I'm going to make a table with my x's. I'm going to do 41, 38, 39, 45, 47. And then in my next column, I'm going to do x minus mu. Now, what this looks like is doing my x value minus the mean. So 41 minus 42, that would give me negative 1. Why did it do that? 41. Okay. No, this should be a 42. Wait, come on. 42. Okay. 38 minus 42 equals negative 4. 39 minus 42 equals negative 3. And then I keep going. So 45 minus 42 is positive 3. 47 minus 42 is 5. Now, let's say you're doing this and you forget you have to square like they're needing in the formula. If I add these up and I do the sum of x minus mu, I would find that this is 0. That should send up a red flag to you to say, wait a minute, I'm not done yet. The only way you should have 0 variance is if the data points are all the same. Are all the data points the same here? No. So that should give you a red flag to say, wait a minute, hold up. I left a step out. So now I like I'll go through it, I'll square them. X minus mu squared. Negative 1 squared gives me 1. Negative 4 squared gives me 16. Negative 3 squared is 9. 3 squared is 9. 5 squared is 25. Now if I add these up, the sum of the squared deviations, I'll get some positive number. Let's see, that's going to be 25, 25 is 50. I should get 60 here. Okay, so let's go back to our formula. Sigma squared is equal to the sum of the squared deviations divided by our samples, or not our sample, our population size. So that's going to be 60 divided by 5, which is 12. And then this is going to be dollars squared. This is our population variance. Okay. Now it says and standard deviation. So standard deviation is simply the square root of the variance. So we would have to do the square root of 12, which is, let's see here, square root of 12, 3.4641, etc., etc. We're dealing with money here. So 3.46. But really, this is thousands. Oh, hold on. Let's think about this. This is thousands of dollars. See up here where it says in thousands? So 3.46, this shouldn't even say dollar squared. This should say $1,000 squared. $1,000 squared. That's what that would look like. So 3.46. If I wanted to do that, let's times that by 1,000. $3,464, and we'll just leave it at that. So $1,000. Or you could say 3,464,000. I just left it at that. So this is your population standard deviation. Okay. That's typically what we would quote if we were to summarize this data. So if I wanted to kind of summarize the data, so in summary, the mean is $42,000 with a standard deviation of $3,464. There we go. I should clarify here. The population mean is 42,000 with our standard deviation. Okay, so that is population. Now, example 2, we're going to deal with samples. So pull that up, go back here, insert screen clip. Okay. In a study of high school football players that suffered concussions, researchers placed the players in 2 groups. Players that recovered from their concussions in 14 days or less were placed in group 1. Those that took more than 14 days were placed in group 2. The recovery times in days for group 1 are listed below. Find the sample variance and standard deviation of the recovery times. So they want sample variance and standard deviation. They're telling us right here exactly what they want. What is the formula for that? It's going to be S squared because we're dealing with a sample. That's going to be the sum of the squared deviations divided by n minus 1. Okay, so what's our n? How many observations do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is equal to 12. There's 12 observations here. Now I need to get my x bar. X bar is going to be the sum of all the x's divided by how many I have. So 4 plus 7 plus 6 plus etc. all the way till the end. Divided by 12. Okay, so let's add those up right quick. 4 plus 7 plus 6 plus 7 plus 9 plus 5 plus 8 plus 10 plus 9 plus 8 plus 7 plus 10. 90. Divide that by 12. 7.5. Okay. So if we were to do this by hand, we go through the same process as before. Start our x out. And we would say 4, 7, 6, 7, 9, 5, 8, 10, 9, 8, 7, and 10. And then we do x minus x bar. So same as before, but now we're dealing with x bar instead of mu. 4 minus 7.5 gets us a negative 3.5. 7 minus 7.5 is a negative 0.5. 6 minus 7.5, negative 1.5. We're going to have negative 0.5 again, positive 1.5, negative 2.5, positive 0.5, positive 2.5, positive 1.5, positive 0.5, negative 0.5, and 2.5. Okay? And then we want to square them. X minus x bar, all squared. So I do not know 3.5 squared by heart. So I'll get that. It's going to be 12.25. Okay. 12.25. This is going to be 0.25. 2.25. That looks horrendous. 2.25, 2.25, 6.25. 0.25, 6.25, 2.25, 0.25, 0.25, 6.25. Okay, there we go. So I just squared the previous column. Now, for my formula, I need to add them up. So the sum of x minus x bar squared is equal to, if I were to add all of these up, I would get 39. Okay, so let's plug into our formula now. S squared is equal to the sum of x minus x bar squared over n minus 1. So I would end up with 39 over 12 minus 1, which would get me 39 divided by 11. With 3.55. And then here we're going to be, I think these are talking about days, right? Recovery time in days. So 3.55 days squared is our sample variance. Sample variance. Now, if I want the sample standard deviation, that's just the square root of S squared. So that's going to be the square root of 3.55. Now, with me using a calculator here, I like to use the whole number. So I'm going to do control square root, go up and grab the full value, and it's going to give me 1.88. 1.88 days. So there is my sample standard deviation. Okay, so notice we have the mean, and we have the variance, and we have the standard deviation. Because we have to get the mean to be able to get the variance, to be able to get the standard deviation. So let's do a little summary for our data. In summary, the mean recovery time was 7.5 days with a standard deviation of about 1.88 days. Which means if I was 1.88 days below or above the mean, that would not be surprising to me. So I could be above or below and not be surprised at all. Now, I do want to show y'all how to do this on the calculator. So, let me get to the calculator. I'm using a TI Inspire in this video. I'm sure if you look online, you can find steps for the TI-84, the TI-30 or 36. I'm just going to demonstrate this using the TI Inspire. So this isn't the only way to do it. This is just how I like to do it. Okay. So what I'm going to do is create a spreadsheet. And then I'm going to name my column. So I'm dealing with days here. So I'm going to call column A days. And then I'm just going to enter the raw data going down on column A. 4, 7, 6, 7, 9, 5, 8, 10, 9, 8, 7, 10. Okay, I put in all my data. Now you're like, are you going to build that table? Nope. I'm going to let the calculator analyze everything for me. So to do that, you go to Menu, 4 for Statistics, 1 for Stat Calculations, and we're going to do what are called one variable statistics. I have one list, and it tells me it's in column A. I like to name it so I know darn sure I'm picking the right list. I called my list Days. Okay, frequency. I kind of leave all the rest of this the same, and then I make sure where it puts it is not in the column my data is in. My data is in column A. That says B. We're good. Hit OK. Now let's look at what it gave us. It gave us X bar, 7.5. Sweet. It gave us S, 1.88294. Hey, that's what we got. It also gave us sigma. Now, we don't want sigma because this is a sample. We want, if we were doing the previous example, we would want sigma, because we're dealing with a population. So I'm going to see if I can do it. Can't cancel. I can do this. That window. Tools. There we go. Okay, I'm going to just screenshot this and put it in here. Insert screen clip. There we go. Just so I can talk about it. Okay. Nope, I don't want it all the way down there. I want it up here, please. There we go. No, come on. Okay, so let's again just kind of mention what these are. This is our sample mean. This is our sample standard deviation. Now, there's some other things on here. This is a population, so we don't want this because it's our population standard deviation. And this is not a population. We don't have a population. Okay. So I'm going to put another note on here. Those of y'all watching this, it won't matter. But for those not, see video for calc steps. Okay, so there's the difference between sample and population, variation, and standard deviation. In the next video, we'll talk about the empirical role and possibly Chebyshev's inequality. But for now, that is it.